वेलकम यू ऑल। आज का लेक्चर होगा, जो कल का लेक्चर था लेक्चर जो था दैट वाज रिलेटेड टू एंगुलर दिस momentum, angular velocity and angular acceleration. Now as we know, the change in linear momentum is equal to the applied force, which is Newton's second law. Similarly, change in angular momentum is also a force, but in rotational motion that force is called torque. So the way you have change in angular momentum dp by dt is equal to applied force according to Newton's second law. If external force is zero, the momentum remains constant. Similarly, the change in angular momentum d by dt gives torque, and torque is we can say हम रेक्टिलिनियर मोशन में फोर्स कहते हैं और रोटेशनल मोशन में उसी को टॉर्क कहते हैं. और angular momentum, change in angular momentum gives torque, and change in linear momentum gives applied force. So there is a relationship between angular momentum and torque, and derive the relation for the torque. So we know L, angular momentum, is equal to R cross P. As we have discussed it in a vector form, that angular momentum L is equal to R cross P. Differentiating with respect to P, we get dl by dt, that is change in angular momentum per unit time, gives a d by dt of R cross P. Here you know that's the differentiation product rule. If a d by dx of uv, you have the differentiation of u unchanged u, differentiation of v plus v unchanged differentiation of u. अगर आपका दो फंक्शन है दैट्स आर व्हिच आर इन प्रोडक्ट फॉर्म, you have to keep one unchanged, the differentiation of other, then keep another unchanged and differentiation of other. Similarly, you have a cross product in between the two, so we are not touching the cross product, but we have a differentiating using the product method. So differentiate this dl by dt comes out to be equal to r cross dp by dt. R को ऐसे हो रहने दिया और d by dt या p, फिर प्लस, अब हमने p को ऐसे ही रहने देना है p क्रॉस dr by dt. So you know this is r cross this dp by dt. This is dp by dt got external force F. So I can write here F is r vector plus p is mass m into v, and is across dr by dt. Dr by dt is the rate of change of displacement per unit time, gives velocity v, that gives v. So you have a cross a. If you have a cross a, अगर एक वेक्टर को अपने ही वेक्टर के साथ क्रॉस प्रोडक्ट करेंगे वो कितना बनेगा, वो मैं a mod of a and angle of sin theta. Sin between a and a is 0 because both are same vectors. So sin 0 is 0. This whole thing becomes 0. The cross product between the same two vectors is 0. Here we have a cross product between v and v. So v cross v will be equal to 0. This portion will be equal to 0, and I have replaced p is equal to m cross m into v. So you get r cross f. And this change in angular momentum is known as torque. The torque is the cross product of position vector r and the applied external force F. This is a torque. So I can write a torque again. The torque can be written as torque is equal to r into F into sine theta and unit vector direction vector. So I will not mention it here. So if theta is 90, then sine 90 unit torque is equal to rf. So torque is maximum when the angle between r and f is 90 degree. So for a circular motion, your r is always like this, and change in angular momentum is always tangential. So they have a 90 degree, that means torque will be maximum. So if the angle between r and dp by dt is not 90 degree, if it is 0, then there will be no torque. So torque has maximum value and theta is 90 degree, and the relation between torque r cross f, then you keep this r cross f gives a torque. You can also write it like way, इसको हम ऐसे भी समझ सकते हैं that torque is equal to f r sine theta. This is a vertical component or a perpendicular distance. So torque is equal to force into perpendicular distance. The simple definition of torque. What is torque? It's simply the product of force into perpendicular distance, because I have taken here sine r, but component of the r, because if r is making an angle theta, then you have to resolve the r. The r का जो sine component है, you have to multiply that with the applied force direction के साथ. The cross product जो उनके दरमियान होगा, you will get the torque. So there is again the change in angular momentum is torque. Change in angular momentum gives torque. So torque is like an external force. As I said, the dp by dt is equal to F external. If F external is equal to 0, then dp by dt is equal to 0, and differentiation of P is 0 only when P is constant. Similarly, you can show here, if torque is 0, external torque is 0, that indicates dl by dt is equal to 0. This implies L is constant. क्योंकि constant की difference 0 होती है. So when the L is constant, means torque is 0. So the angular momentum remains constant. This is the law of conservation of angular momentum. So when linear momentum is constant, your external force is 0. Net F is 0. When angular momentum is constant, your torque is 0. But torque is 0 means there is no change in angular momentum. Change in angular momentum takes place when there is external force. And change in linear momentum also takes place when there is external force. When there is no external intervention, the system remains as it is. It moves with a uniform velocity, it moves with the same angular momentum, it keeps its velocity constant, it keeps its acceleration 0. So in that very case, the torque is 0 and your L is equal to constant, means law of conservation of angular momentum. Now the components of torque. What are the components of torque? Torque is equal to R cross F. So I can write I, if R, let me write down the components, vector form R, because R has 3 components. So R is equal to xi plus yj plus zk, and F2 has its component fxi, fyg, and fzk. So I can write torque in vector form. Torque is equal to I, j, k. So you can write here magnitude of R, there is x, y, z, this fx, this fy, this sz. Similarly, the way we have done yesterday for angular momentum, similarly we can do torque is equal to this line and this line drop I times this line and this line drop y fz minus z fy. These z and y are subscript, means force along the y axis, force along respective axes. First is plus, then minus j into this line and this line we drop, you have x fx z x. So x fz minus z fx plus k into this is k here. So this line, this we drop x fy minus y fx. So this can be written as torque is equal to y fz minus z fy times I. यहाँ से माइनस कॉमन निकाल दीजिए, माइनस प्लस जे, अक्सर किताबें माइनस कॉमन निकाली है, सो मैंने भी यहाँ निकाला, अदरवाइज यू कैन कीप लाइक एज इट इज. z fx माइनस f x z f, यहाँ से माइनस कॉमन निकाल दो, ये प्लस बन गया, यहाँ इसका तो माइनस था ही नहीं, यहाँ तो माइनस बनेगा, यहाँ तो माइनस बाहर आ गया, प्लस टाइम्स जी, यहाँ से हम जी यहाँ लिखेंगे लास्ट में, प्लस एक्स एफ वाई माइनस वाई एफ एक्स टाइम्स के. So this is torque. This is torque along the x-axis. This torque x times I. This is torque y, torque along y times g, and this is torque along z axis. This is torque along z times k. So this is the components of torque along the respective axis. So torque along axis again separate between as y f z minus z f y. Torque along y axis is equal to z f x minus x f z times g, this, and torque along z axis is equal to x f y minus y f x. These are the torques along the respective axes. So ये थे components of torque. This is how we can write torque in a vector form. अगर आपका R दिया होगा वेक्टर फॉर्म में, F दिया होगा, सीधा डिटरमिनेंट फॉर्म लीजिए या किंबर्स रूल इस्तेमाल करके आप निकाल सकते हैं. Also, we have angular momentum is equal to R cross P or RP. If theta is 90 degree, if theta is case 90 degree, then you have RP. So L is equal to R, P and M into V, because P is equal to mass into velocity. We know yesterday the relation between linear velocity and angular velocity, V is equal to R omega. And you can write R M into R omega. So L becomes R into R square, becomes M R square into omega. So L is equal to I omega. While I is equal to M R square is the inertia. The way in rectangular motion we have mass, and here we write inertia instead of mass, and this angular velocity. So angular momentum P is equal to mass into velocity in rectilinear motion. In rotational motion, instead of P we have angular momentum is equal to mass into velocity, but in rotational motion the mass is analogous to inertia. The inertia is I, that's mr square, into angular velocity. It's mass into velocity becomes angular momentum, mass into linear velocity becomes linear momentum. This is a relation between angular velocity and moment of inertia, or relation between angular velocity and angular momentum and angular velocity and angular momentum. Yeah, this is a relation between angular momentum and inertia. So this is how we can write in terms of rotational motion. और इस पे न्यूमेरिकल्स भी आ सकते हैं. इसके बाद you have like torque is equal to I alpha. That also relation, that torque is equal to I alpha. That torque, जैसे force is equal to mass into acceleration. Here is in a rectilinear motion. You have in case of rotational motion, force is against this torque. Torque is against the force. Mass को हम momentum में लेते हैं. This inertia में लेते हैं. And alpha is angular acceleration. So your force is equal to mass into acceleration. But in case of rotational motion, you write torque is equal to mass. Mass के बदले हम inertia into angular acceleration लेते हैं. ये भी आप solve कर सकते हैं by using different methods इनकी relationship भी. Thank you very much. ये छोटे-छोटे questions थे जो एक दो मार्क्स के आ सकते हैं, जैसे ये जो. इसके बाद जो इंपॉर्टेंट क्वेश्चन इसमें है, दैट्स पैरेलल एक्सिस थ्योरम, परपेंडिकुलर एक्सिस थ्योरम, मोमेंट ऑफ इनर्शिया एंड सेंटर ऑफ मास. वो 3-4 क्वेश्चंस हम भी 1-2 दिन में कंप्लीट करने वाले हैं. थैंक यू वेरी मच.